Hello everyone, in this video we are going to discuss the solution for Neonma platform. So let's discuss our question first, then we will move on to its solution. So in the first time we have been told that we have some arrival time and departure time of the trains that are going to reach a railway station. Okay, now what we have been given is we need to find the minimum number of platform required by the train station so that no train is kept waiting, or which means that no train is outside the station. Every train should be present inside the station on some platform. Alright. And also we have been told that train are going to arrive and leave on the same day. And now we have been told that arrival and departure for the same train can be same. Meaning if a train is arriving at 10 a.m., it won't leave at 10 a.m. also. Okay. But we have been told that arrival we can have arrival time of one train equal to departure time of another train, which means that we can have one train arriving at 9 a.m. and one train leaving at 9 a.m. Okay, but for the same train it won't be possible. Now for this case in which one train is arriving at 9 and other train is leaving at 9, we can't use the same platform, meaning that my train is leaving at 9 and on behind my 9 a.m. arriving train will be kept. It won't be possible, right? So for that we will need one more platform. So that was all about the question. Now let's try to discuss its solution. Okay, so let's see our solution now. So let's consider this my station. Let's say that this is my station. Okay, now this time is given in 24-hour clock. Okay, now at 900 hours one train arrives. Let's name these trains as well: T1, T2, T3, T4, T5, T6. Okay, now T1 train arrives at 900 hours. Okay, now there are no platforms, so we need to create one platform. Let's say this is my platform P1. T1 train arrives and is kept. Okay, at 9:10 it leaves. Okay, so train 1 leaves. At 9:40 another train arrives. So platform number 1 is now occupied by train 2. Okay, now 9:50 train 3 arrives, but train 2 won't be gone till 12 o'clock. So it means that T3 will need to have some other platform. So T3. Okay, now T4 train comes at 11, but at max, at minimum 11 at 11:20 T3 will leave. Till then there is no platform available. Platform number 1 is not available and platform number 2 is not available. So we need to create platform number 3 also for keeping my train 4. Okay, now train 5 comes at 3, but at 11:20 T3 will leave. At 11:30 T4 will leave, and at 12 T2 will leave. Okay, at 1500 hours T5 and will at 1500 hours at 3 o'clock when T5 will arrive, all the platform will be empty, so it can take any platform. Let's say P1 platform will be taken by T5. Okay, now P2 and P3 platform are still empty. At 6 when T6 will arrive, it can take any of these platforms. Okay, so after that, no train are going to come, and we actually don't need to take in consideration departure time for T5 and T6 as well. But let's say 1900 hours, T5 will leave, and at 8 or 2000 hours, T6 also leaves. Okay, so at minimum, three platforms are needed. So, how we can find this? So, first we are going to do what is sort both of them. Now, why we are sorting both of them? Because arrival time is going to tell me when my train is going to arrive, and departure time is going to tell me when my train will leave. So, at any arrival time, my platform will be filled. Some platform will be filled, meaning that some number of trains have arrived. Okay, this arrival time signifies that maximum train is at the station will increase. Okay, and my departure time will tell me that platform is empty, and my maximum number of train will decrease. Okay, okay, and what we need to find is the minimum number of platform. We don't need to know when 9 a.m. train is going to leave. Is it going to leave at 9:10, or is it going to leave at 11:20? Okay, we just need to know at what time the platform will be empty for the next train. Okay, so for that we need to sort both of them. Now you must be asking that arrival time is already sorted, so why we are going to sort it both of them? So consider the case in which I have one more arrival time. Okay, like this, and it leaves at 2100 hours. All right, this is not 3, this is my curly braces. All right, so if this is the case, then both of this train will come before 9 a.m. train. It will leave at the last. So that's why we need to sort both of them, because it isn't given that both of them or any one of these arrays will be sorted. Okay, so we need to sort them. Okay, let's sort them. 0900, 0940, 0950, 1100, 1500, 1800. This is my arrival. Sure. 0910, 1200, 1120, 1130, 1900, and 2000. Okay, so this is how my times will be sorted. Okay, now we are going to keep one point for I at my arrival time and one point at j my departure time. This is going to tell me when the maximum number of train on my station is increasing, and this is going to tell me when the maximum number of train that is or current number of train is decreasing or not at one time. Okay, so ARR I less than equal to departure of j. Now remember, this I and j may not be pointing towards the same train. For example, this I should have written 1 1. Oh, I have forgotten to sort them. Let's do this. 1120 1130 1200. So if this is the case now, it means first of all, what I was saying, that this I and J pointers are all not always going to represent the same train. Look at this. This is representing the same train, but if I will move I here and J here, then both of these trains will be different. All right. Now, if this is the case, which means that departure time at this time, no train is going to leave. So it means that maximum number of train on my station is going to increase. Maximum train is increasing. Now I'm going to increase my arrival time. Okay. If this is not the case, meaning that if departure time is more than my arrival time, it means that some train is leaving and my maximum number of train will decrease. Max train will decrease and I will see the departure for the next train. Okay. And how about the number of platform? That's the one thing that we are most important. Max platform. Now this platform is going to be dependent upon the previous number of platforms and what the current number of train or the maximum number of train that are present. Okay, so this is going to be my basic formula or basic algorithm, you should say. All right, and let's say this is representing max train and this is my platform. Let's do a dry run. Okay, so first my I is here, J is here. Let's start both of them with 0. Okay, initially there are no trains and there are no platform. All right, this is going to happen and my max train will increase and my I will move here. All right, now same thing is going to happen. No, max departure time is less than my arrival time, which means by the time this train arrives, one train is going to leave. So after I have acquired one train, the size of platform will increase to 1. Okay, where was I? The number of train will decrease. So now is 0 and my J will increase. J will move here. Now same thing. This is going to add 1 and I will move forward. And now again same thing is going to happen. This is smaller than my departure time, which means one train is going to come and it will increase to 2. Same thing. And now my max train is increased to 2, so it means there should be at least 2 platform now. Now at 11, my 11 is 1100 hours, still less than 1120. So I will move forward and max train will become 3 and number of platform will increase to 3. Minimum platform number required will be 3. Now I have arrived at 1500 hours. Now before this train comes, this train is going to leave. So J is going to move forward. Again, this condition will run. And now it will move here. Again, same condition. 1500 hours meaning 3 p.m. and 1200 hours means 12 p.m. So this train is going to leave before this train arrives. So J will move forward again, and now there are no trains on the platform. When this case will arrive, will mean that I will increase and number of train will increase as well. Now number of train will become 1, max number of train, and same case I will increase again, and now maximum number of train becomes 2. Now I don't have to actually check for that number of departure time because I have checked for the all number of trains. I all the trains that are going to come on the station for one day has already come. Now I don't have actually care when they leave or not. Okay, so I will end my loop here when this I or maybe J which is at the end. Okay, after that what I have is number of platform is equal to 3, which is the minimum number of platform that is required by the station to accommodate all the arriving trains. Okay, so that's all for the approach. Now let's implement it. Right, then let's code it now. Okay, so first thing what we were going to do was sort our arrival time and departure time. So I'm going to use is dot sort my arrival time, and same thing for my departure time as well. Okay, after that I will need my ing int I equal to 0, j equal to 0, and max number of trains, let's start with 0, number of platform also 0. Now my loop I less than n and j is less than n. Okay, what is n here? N is the number of trains, so let's write it. Int n equals arr dot length. That's it. Now the same condition that we have been discussing, arr of I is less than equal to departure of j, meaning that number of train on the station has been increased. So max train plus plus and I plus plus as well. If this is not the case, then number of train on station has been decreased. So max train minus minus and j plus plus. Now we just need to do if platform number of platform can hold the maximum number of trains or not. So max platform comma max train, if it cannot hold then number of platform will increase. So that's it. Now we just need to return the number of platform. Okay, so let's now run it. So we got successful submission for our sample test case. Let's submit it. So we got 10 out of 10, which means our logic was correct and our programming was also correct as well. Okay, so that is it for the solution of this minimum number of platforms problem. So that's all for this video, and I will see you in the next one.